Welcome back. Chapter 2, Operating Model. Let's go. But first, a quick recap. Right, so who is an IoT customer? One way to define them is any business that has a base of unconnected objects at the core of their operations. This mainly applies to specialized IoT networks for unconnected objects. So what's the value proposition? Well, a way to connect and communicate with those objects. How does one make money from it? Well, it depends on where you are in the value chain, and we'll get to the different players in a bit. In the case of a network operator, they make money by charging license fees per device connected to the network. We will do a detailed cost model and cost breakdown in Chapter 3. What do you need to make it happen? Well, pretty much the infrastructure setup we described in Chapter 1b. It has its own challenges, but nothing that can't be overcome. It just depends on one's pocket and how the required investment balances out relative to the return on the said investment. Now let's get into the functions and what it takes to extract value from that investment. So the network operator's core responsibility is to manage the network. They would have built all the infrastructure required to monitor and maintain the network, as well as support all parties with objects connected to the network. We will define partnerships in detail shortly while describing the parties involved in the value chain. The connection of objects to the network is an exercise that typically happens when a new set of objects from a new client are onboarded onto the network. There's a whole design process that needs to happen to map out what is required for the objects to be able to transmit to the network. As we said before, in the case of a traditionally unconnected object such as a gas heater, it's a matter of attaching a combination of a sensor and the specialized IoT network-compatible transmission device to the heater, whereas in the case of an electronic device, there might be some software development and integration required. Perhaps the electronic device has an active USB port, but the stack needs modification to be able to pull from the device and allow the IoT transmitter attached to the USB port to collect and transmit this data to the base station. The electronic devices might require a software upgrade to allow this capability to function. The client or object owner's product and technical teams would have to work hand in hand with the network operator's team to onboard these devices onto the network and manage them going forward. The next functions are the collection of data, as well as the management of the data. We've discussed this in Chapter 1b. There's the global cloud storage on the network operator's side, and then a data ecosystem and related storage on the client side. Lastly, the analysis, insights extraction, process automation, and other related activities. Right, now let's get into the partners and stakeholders. You have the network owner, the guy that undertook the massive task of creating the specialized network technology. This would involve selecting a communication frequency, defining the specification of how to communicate over that network, developing the transmission and reception firmware and software from objects to base station. They would also typically host the global cloud to which base stations would transmit collected data. They are also responsible for the base station design as well as specifying the chip to facilitate communication from object to base station that new electronic device developers can embed into their devices at design and manufacturing stage to enable compatibility to the network. This is the intellectual property they develop in order to monetize the network. The cloud basically facilitates the collection of information from base stations to the client storage. Then you get the network operator. What's the difference, you ask? So, the network owner owns the IP to the specialized IoT ecosystem, but they don't want to lay this network all over the world. It's too expensive and they just don't have the capital or capacity. So they approach infrastructure management companies in various countries and they say, hey, let's partner together and lay our network in your country. You get customers that would connect their objects to this network, and then we'll share the license fees. So for their role, the network operator gets to monetize the network and then pay over a portion of the revenue to the network owner for using their IP as well as their global cloud. The network operator becomes the go-to guy for that region or country. They are, for all intents and purposes, responsible for the network in that region or country. some instances, the network operator might employ a network maintenance partner to take care of the support side of things. This would typically be a party that already has a functioning network maintenance ecosystem across the given region, with an operating model already in place to maintain networks spreading across city hubs as well as remote areas. Lastly, the party that actually makes this whole situation viable, the client. This is the guy that has a large base of unconnected objects. They need a low-cost, manageable mechanism to access their objects once they are in field for a variety of reasons. We referred to these reasons as KPIs in the previous chapter. So let's quickly summarize the operating model in terms of the functions of each party in the value chain. And there you have it, your specialized IoT network operating model. Time to go do a deep dive of the costs in Chapter 3. See you there.